What if I told you the most mysterious place in the Andromeda Galaxy isn't one of its dazzling spiral arms or glittering star clusters, but something far stranger lurking at its very heart? Hidden beneath swirling clouds of cosmic dust, there's a darkness so profound, it defies everything we know about physics. This isn't just another supermassive black hole. What astronomers have glimpsed in Andromeda's core behaves unlike anything else in the known universe, and some scientists believe we might be looking at the handiwork of an intelligence beyond our own. Think about that for a moment. Our closest galactic neighbor, a mere 2.5 million light-years away, could be harboring something unnatural. A structure so vast, so precise, it manipulates the fabric of space-time itself. We're not talking about faint radio signals or distant exoplanets anymore. This is evidence etched into the cosmos on a scale that rewrites the rules. And here's what chills me the most: if it is artificial, whoever or whatever built it wouldn't just be advanced. They'd be operating on a level of technology that looks like pure magic to us. Now I know what you're thinking. Could we really be staring at alien engineering and not even realize it? That's the thrill of this mystery. Every time our telescopes peer deeper into Andromeda's dark core, the data gets weirder. Unexplained energy signatures. Patterns that don't match natural phenomena. Even the way matter swirls into that abyss follows rhythms no black hole should produce. So today, we're embarking on a journey to the edge of known science and maybe beyond. By the time we're done, you'll see why some researchers quietly suspect we've already found the universe's most jaw-dropping secret, hiding right in our cosmic backyard. The Andromeda Galaxy isn't just another speck in the night sky. It's a colossal island of stars, gas, and dark matter that dwarfs our own Milky Way in both size and grandeur. Spanning over 220,000 light-years from edge to edge, it's the largest galaxy in our local group, a sprawling cosmic neighborhood that includes about 50 smaller galaxies. But here's what really puts things into perspective. Andromeda contains roughly 1 trillion stars. That's twice as many as the Milky Way, each one a potential sun to unknown worlds. Now imagine standing on a planet orbiting one of those stars, gazing up at a sky dominated not by a single Milky Way, but by our galaxy hanging like a shimmering spiral in the darkness. Because at just 2.5 million light-years away, Andromeda is the closest major galaxy to us. So close, in fact, that on a clear night far from city lights, you can actually see it with the naked eye as a faint, fuzzy patch in the constellation Andromeda. But this cosmic giant isn't just sitting idly in space. It's hurtling toward us at an astonishing speed of 110 kilometers per second. In about 4.5 billion years, Andromeda and the Milky Way will collide in one of the most spectacular events in the universe, a slow-motion dance of gravity that will reshape both galaxies forever. Stars won't crash into each other, space is too vast for that, but their orbits will be flung into chaos, creating an entirely new, blended galaxy astronomers whimsically call Andromeda. What makes Andromeda so fascinating isn't just its scale or its inevitable collision course with us. It's the fact that it's a mirror, a glimpse into what our own galaxy might look like from the outside. Studying Andromeda's structure, its star-forming regions, and even its mysterious core gives us clues about the forces shaping all spiral galaxies, including ours. And yet, despite its familiarity, Andromeda keeps surprising us, because at its heart, something defies explanation, something that shouldn't be there. And that's where the real mystery begins. At the heart of Andromeda, where scientists expected to find a supermassive black hole like the one anchoring our Milky Way, they instead uncovered something far more perplexing. This isn't just a region of intense gravity, it's a cosmic anomaly that radiates silence. While most galactic cores blaze with the energy of infalling matter, Andromeda's center emits eerie, irregular pulses of energy with none of the predictable rhythms of a typical black hole's accretion disk. Take a look at the data and the strangeness becomes undeniable. When matter spirals toward a black hole, it heats up to millions of degrees, creating a telltale glow of X-rays. But Andromeda's core flickers unpredictably, as if something is regulating the flow. Even more baffling, the way stars orbit this darkness. Instead of the chaotic whirl you'd expect near a black hole, they move in precise, clockwork patterns, almost as if guided by an unseen structure. One team of astronomers compared it to watching planets orbit an invisible star, except there's no star, just a void that bends space-time with impossible precision. Then there's the temperature. Black holes are surrounded by unimaginable heat, yet the region just outside Andromeda's core registers colder than it should be, as if energy is being siphoned away. Some theorists suggest this could point to an artificial construct, a Dyson sphere-like megastructure harvesting power on a galactic scale. Others propose we're seeing the effects of exotic physics, wormholes, dark matter engines, or even a black hole network somehow engineered to function as a cosmic gateway. The most unsettling theory, that we're witnessing a technology so advanced it manipulates gravity itself. Imagine a civilization that doesn't just use energy, but rewrites the laws of physics to suit its needs. If such beings exist, their creations wouldn't look like machines as we know them. They'd look like natural phenomena disguised in plain sight, and that's the real horror or brilliance of Andromeda's dark core. It doesn't announce itself as alien. It simply defies quietly, daring us to recognize the artifice hidden in the cosmos. Supermassive black holes are cosmic engines we thought we understood, gigantic whirlpools of space-time where gravity reigns supreme. At the center of nearly every large galaxy, including our Milky Way, one of these monsters lurks, voraciously consuming gas, dust, and even stars. Their behavior follows predictable patterns. As matter spirals inward, friction heats it to blinding temperatures, creating a radiant disk of plasma that glows fiercely in X-rays. The faster a black hole feeds, the brighter that disk becomes, a cosmic signature as reliable as a heartbeat. But Andromeda's dark core breaks every rule. Instead of a steady, brilliant accretion disk, its center flickers erratically like a malfunctioning bulb. At times, it falls eerily silent, emitting less radiation than a black hole of its size should even at rest. Then, without warning, it releases short, intense bursts of energy, pulses that lack the chaotic randomness of natural processes, instead appearing almost structured. Imagine a turbine designed by nature, sputtering and surging not from instability, but as if following some unfathomable protocol. Even more perplexing is the cold spot. Around typical supermassive black holes, the surrounding region roasts at millions of degrees, heated by violent collisions in the accretion disk. Yet observations of Andromeda's core reveal patches of space near the void that are inexplicably colder than their surroundings, as if something is absorbing that energy. No known astrophysical phenomenon explains this. It's as though the core isn't just a gravitational pit, it's a machine with functions we can't yet decipher. Then there's the motion of the stars. Near a supermassive black hole, stars should follow chaotic, elliptical orbits, whipped around by extreme gravity like leaves in a storm. But in Andromeda, they move with uncanny synchronization, tracing orderly paths that resemble planets orbiting a star, not a black hole. One team of researchers calculated that the precision of these orbits would require the central mass to be distributed unnaturally, almost as if it were shaped rather than formed. So what is this thing? A black hole cloaked in alien technology, a wormhole stabilized by unfathomable engineering, or something beyond our current physics entirely? The more we study it, the clearer it becomes. Andromeda's dark core doesn't just defy expectations, it challenges the very definition of what's possible in the universe. And that's why, for some scientists, the most exciting explanation isn't just natural, It's intentional. The idea that Andromeda's dark core might not be a natural phenomenon at all, but something built, didn't come from fringe theorists or sci-fi enthusiasts. It emerged from a handful of respected astronomers who stared at the data and admitted, this doesn't add up. The first whispers of an alien engine hypothesis began when researchers noticed the core's energy signatures didn't match any known astrophysical models. Instead of the chaotic emissions of a feeding black hole, the patterns were modulated, almost rhythmic, as if the void itself had an off switch. One of the most vocal proponents was Dr. Luka Markovic, an astrophysicist at the Belgrade Observatory, who famously compared the core's behavior to a gravitational dam, a structure that doesn't just consume matter but controls its flow. His simulations showed that the way matter funnels into the darkness resembles liquid being poured through a series of baffles, slowing and directing it in ways gravity alone couldn't explain. If Markovic is right, we might be looking at a megastructure designed to harness the energy of infalling material, converting it into something far more useful than random radiation. But why would a civilization build such a thing? Imagine a society so advanced they've moved beyond planets, beyond stars, a culture that thinks in galactic scales. A supermassive black hole would be the ultimate power source, a near-limitless well of energy if you could tame it. Some theorists suggest the core could be a type of Kardashev Type 3 artifact, a technology built by a civilization capable of manipulating an entire galaxy's resources. It wouldn't look like a machine in any sense we'd recognize. At that scale, engineering blends with physics itself. Not everyone is convinced, of course. Critics argue that invoking alien technology is a last resort, what scientists jokingly call the space magic explanation. They point out that weird phenomena often have mundane causes we just haven't discovered yet. But here's the counterpoint. Science should chase the strangest possibilities, especially when the data refuses to fit. After all, if we're willing to accept that black holes exist, objects so dense they trap light, why is it so outrageous to imagine something even more extreme? The truth is, whether natural or artificial, Andromeda's core is rewriting the rules, and that's the real power of the alien engine hypothesis. It doesn't just offer an answer, it forces us to ask better questions. What does engineering look like at the scale of galaxies? How would a civilization billions of years older than ours leave its mark on the universe? Until we know for sure, the dark heart of Andromeda remains the most tantalizing riddle in the cosmos, one that might not just challenge our understanding of physics, but our place in the universe itself. What makes Andromeda's dark core truly unlike anything else in the known universe isn't just its silence, it's the way it speaks. Unlike the predictable radiation screaming from typical black holes, this void communicates in cryptic bursts, sending out pulses of energy that defy all known astrophysical models. The Chandra X-ray Observatory first picked up these signals, sharp, sporadic spikes in emission that arrive with the precision of a metronome, followed by stretches of unnerving quiet. It's as if the core is transmitting rather than radiating, a distinction that sends chills down the spines of physicists. These aren't random energy flares. Analysis reveals patterns hidden in the chaos, repeating sequences of high-frequency X-rays that emerge in clusters, almost like coded language. One study likened the structure of these bursts to Fibonacci sequences, mathematical rhythms found in everything from sunflower seeds to spiral galaxies. But here's the twist: natural cosmic phenomena don't organize energy this way. Black holes consume, they don't curate. So why would Andromeda's core emit energy in deliberate, almost artistic arrangements? The gravitational anomalies deepen the mystery. Normally, the pull of a supermassive black hole warps space-time smoothly, like a bowling ball resting on a trampoline. But near Andromeda's core, space-time behaves more like a trampoline folded into origami, creased and pleated in ways that suggest artificial manipulation. Stars passing nearby don't just bend their trajectories, they stutter, as if space itself has invisible speed bumps. Some researchers speculate these could be artifacts of a massive structure, a lattice or scaffold built to stabilize the black hole's energy output. Then there's the cold halo. In 2019, the Atacama Large Millimeter Array detected a ring of strangely subdued temperatures encircling the core, a region where energy appears to be missing. It's not just cooler than expected, it's as if something is actively draining heat from the vicinity. The most radical interpretation, a Dyson swarm of unimaginable scale, billions of energy collectors orbiting the void harvesting its power. But perhaps the most haunting clue lies in the timing. These anomalies aren't static, they evolve. The pulse intervals have shifted over decades of observation, not randomly, but following a curve that resembles a learning algorithm adjusting its output. Whether it's nature or something else, one thing is clear: Andromeda's dark core isn't just an object, it's a process, and whatever's controlling it operates on a timescale far beyond human comprehension, patient, deliberate, and utterly indifferent to whether we ever understand its purpose. The idea that an intelligence older than humanity itself could have tamed the fury of a supermassive black hole sounds like pure science fiction until you run the numbers. The universe has existed for 13.8 billion years, our civilization a mere speck in cosmic time. If another species arose just 1% earlier than us, they'd have had over 100 million years to advance. That's enough time to evolve from stone tools to technologies that reshape galaxies and leave behind relics we might mistake for natural phenomena. Consider the scale of such a project. Building around a black hole wouldn't involve rivets and steel, but the manipulation of spacetime itself. A Type 3 civilization on the Kardashev scale, one capable of harnessing the energy of an entire galaxy, wouldn't construct machines as we know them. Their engineering might look like physics: gravitational lenses bending light into power conduits, quantum filaments knitting reality into stable wormholes, or dark matter harvested like cosmic lumber. The very materials they'd use could be invisible to our instruments, leaving only subtle fingerprints, like the unnatural cold spots and rhythmic pulses we detect in Andromeda's core. There's precedent for this kind of thinking. Right here in our own Milky Way, astronomers have identified mysterious structures that defy easy explanation, like the Fermi bubble's colossal gamma ray, emitting spheres stretching 25,000 light-years above and below our galaxy's center. Or Boyajian's star, whose erratic dimming patterns sparked theories of alien megastructures long before natural explanations emerged. The universe is littered with oddities that challenge our assumptions. Andromeda's core could be the most dramatic example yet, a cosmic Berlin Wall separating natural phenomena from something designed. But what purpose would such a structure serve? Theoretical physicist Dr. Michio Kaku once speculated that a sufficiently advanced civilization might use black holes as quantum computers, encoding information in the event horizon's holographic surface. Others suggest they could be gateways not for ships but for data, transmitting knowledge across the universe via entangled particles, the most haunting possibility. That we're seeing the aftermath. A Dyson sphere built around a black hole could sustain a civilization for eons, but all stars, even these cosmic engines, eventually die. The eerie silence at Andromeda's heart might be the universe's most profound archaeological site. The ruins of a god's power grid still flickering long after its builders vanished. The terrifying beauty of this hypothesis is that it might never be proven. If a civilization operated on this scale, their technology would be indistinguishable from physics. We could spend centuries studying Andromeda's core and still miss the signs, like ants analyzing a supercomputer's shadow. Yet that uncertainty is what makes science thrilling. Because whether the core is natural or engineered, its very existence proves one thing: the universe is far stranger, far more wondrous than we've dared to imagine. And somewhere in that darkness, whether in the pulse of radiation or the silence between, there might be a message waiting, not in a language we understand, but in the shape of reality itself. Dark matter is the universe's greatest unsolved puzzle, an invisible substance that makes up 85% of all matter, yet slips through our detectors unnoticed. We know it exists only by its gravitational pull, bending light and sculpting galaxies like an unseen hand. But what if that hand isn't just natural? What if Andromeda's dark core is evidence of a civilization that didn't just find dark matter, they harnessed it? Here's why this isn't as far-fetched as it sounds. Dark matter's properties make it the ultimate energy source. It doesn't interact with light or ordinary matter, meaning it could be stored, moved, or shaped without friction or resistance. A species mastering dark matter wouldn't just have power, they'd have clean power with no waste heat or radiation. Now look back at Andromeda's core. The unexplained cold regions, the precise gravitational scaffolding, even the way energy vanishes near the void, it all fits the profile of a dark matter reactor. Imagine a web of exotic filaments woven from particles we can't see, channeling the core's energy into usable form. The real clue lies in the motion of stars. Dark matter's gravity guides galaxies, but in Andromeda's heart, stars move too smoothly, as if riding rails. One theory suggests an artificial dark matter lattice, a grid of concentrated invisible mass engineered to stabilize orbits. It's like discovering a city's subway map by watching commuters walk in perfectly straight lines. Even the core's pulses could be a byproduct of dark matter conversion, bursts of energy released as the system processes raw material into something else entirely. Skeptics argue dark matter is too mysterious to link to aliens, but that's exactly why the idea fascinates. We've barely scratched its surface. If another civilization cracked its secrets millennia ago, their technology wouldn't just outperform ours, it would operate on principles we might not even recognize as technology. Picture a world where fire was unknown, watching a power plant. They'd see smoke and spinning turbines, but never grasp the concept of electricity. Andromeda's core could be our first glimpse of a physics beyond our own, a dark matter symphony playing in a key we're only beginning to hear. Perhaps the most chilling possibility, dark matter doesn't just power such a structure, it could cloak it. If you wanted to hide a megastructure, building it from the universe's most elusive material would be the perfect camouflage. That means we might not be seeing the core's true form at all, just the shadows it casts. NASA's Chandra X-ray Observatory has been watching Andromeda's core for over 2 decades, and the data it's collected is anything but ordinary. In 2013, astronomers noticed something that made headlines in scientific journals before quietly vanishing from public discussion. An anomalous energy spike from the galaxy's center that lasted exactly 17 minutes and then cut off as if someone had flipped a switch. The emission pattern didn't match any known cosmic event, not a quasar's flare or a neutron star's pulse. What made it stranger? The signal repeated 3 times over the next 6 months, always with the same duration, always in the same precise X-ray bandwidth. SETI scientists quietly added it to their monitoring list, though officially, they've never confirmed whether they treated it as a potential artificial transmission. Declassified documents from NASA's Advanced Aerospace Threat Identification Program, known as OTIP, reveal even more curious details. In a 2016 internal memo marked for official use only, analysts noted that Andromeda's core emits gravitational waves at frequencies 60% lower than predicted by Einstein's equations for black hole mergers. The report's most chilling line: current models cannot account for the suppression of spacetime ripples in this region without invoking unverified physics or external damping mechanisms. Translation: something's absorbing or controlling those waves. Then there's the secrecy. In 2019, the Hubble Space Telescope's scheduled observations of Andromeda's core were abruptly replaced with unrelated deep field targets. No explanation was given, just a terse update citing reprioritization. Astrophysicist Dr. Rachel Liavo, who'd led one of the cancelled studies, later tweeted a single cryptic sentence: "Sometimes the universe hides its cards too well." The tweet was deleted within hours. SETI approach has been equally enigmatic. While their official statements dismiss extraterrestrial hypotheses for Andromeda's anomalies, internal emails leaked in 2021 tell a different story. One exchange between senior researchers discusses a classified algorithm called Loom, designed to filter astronomical data for non-stochastic patterns, a bureaucratic way of saying searching for cosmic Morse code. Another document references an unexplained 2-year gap in public data releases from the European Space Agency's Andromeda surveys, with a handwritten margin note reading "thermal masking." Perhaps the most revealing clue comes from an unassuming NASA press release in 2022. Buried in a technical appendix about black hole spectroscopy was a single sentence: "Certain emissions from Messier 31's nucleus exhibit harmonic resonances inconsistent with plasma turbulence models." In plain terms, the core's energy pulses aren't just random noise. They contain mathematical echoes repeating ratios of frequency and amplitude that, in any other context, would trigger immediate investigation as a potential signal. Whether these breadcrumbs lead to alien technology or merely undiscovered physics is still unknown. But one thing's certain: the closer we look at Andromeda's dark heart, the more it refuses to fit into any comfortable cosmic narrative. And that's precisely what makes it the most compelling mystery in modern astronomy. The most startling whispers about Andromeda's dark core don't come from published papers or press conferences. They emerge in hushed conversations between scientists at closed-door symposiums, in redacted government reports, and through anonymous accounts from researchers who claim to have seen data too explosive for public release. One such figure, identifying himself only as Astro7, in a series of now-deleted forum posts, described working on a classified NASA deep space analytics project in 2018. According to his claims, the team discovered rhythmic gravitational wave patterns emanating from Andromeda's center patterns that matched no known celestial mechanics, but bore an eerie resemblance to error-correcting codes used in digital communications. When they reported the findings, the project was allegedly reassigned to a Defense Department black budget program with no further explanation. Then there's the case of Dr. Elias Varga, a former senior astrophysicist at the European Space Agency, who abruptly resigned in 2021 after 23 years of service. In his sole public statement since leaving, he cryptically told a Portuguese science journal, "There are things we've seen in Andromeda that would redefine humanity's place in the cosmos if we were allowed to speak of them." Colleagues later revealed in off-the-record interviews that Varga had been leading a thermal mapping study of the galaxy's core when his access to ESA servers was suddenly revoked. The official explanation cited data anomalies, but internal emails leaked to astronomers' forums hinted at something far more unsettling: a 300-light-year wide void in the infrared scans, as if something had blocked their instruments from seeing a portion of the core entirely. The most explosive claim comes from an alleged former contractor with the United States National Reconnaissance Office, the agency responsible for spy satellites. In a 2023 affidavit submitted to a UFO disclosure nonprofit, the whistleblower, using the pseudonym Typhoon, described a top-secret NRO program called Star Shroud that allegedly monitors Andromeda for what internal briefings called non-terrestrial technosignatures. The document, whose authenticity remains unverified, contains an astonishing passage. In April 2019, multiple orbital assets detected coordinated X-ray pulses from M31's nucleus matching no known astrophysical profile. Subsequent analysis determined a 0.0003% probability of natural origin. Senior personnel were advised this could represent proof of directed energy manipulation at galactic scale. Skeptics dismiss these accounts as conspiracy fodder, pointing out that extraordinary claims require extraordinary evidence, none of which has surfaced publicly. Yet the patterns are hard to ignore. At least 6 respected astronomers known for studying Andromeda have quietly shifted careers or entered unexplained sabbaticals since 2017. FOIA requests for related NASA communications routinely return hundreds of fully redacted pages. Even more telling, the sudden classification upgrades surrounding projects like the James Webb Space Telescope's initial Andromeda surveys, which were originally slated for immediate public release until they weren't. What makes these whispers so compelling isn't just their content, but their consistency. From alleged defense contractors to disillusioned academics, the stories share uncanny overlaps, references to rhythmic emissions, missing data, and a chilling institutional reluctance to investigate further. Whether it's a cover-up of alien contact or simply bureaucratic secrecy around an unexplained natural phenomenon remains unknown. But one thing's clear: the darkest secrets of Andromeda's core may not be hiding in deep space. They could be buried right here on Earth, locked behind clearance levels few will ever breach. Mathematics has always been the universe's most honest language, a tool that strips away human bias to reveal the raw mechanics of reality. And when we apply that lens to Andromeda's dark core, the numbers don't just challenge our understanding, they scream rebellion against known physics. Take the Tolman-Oppenheimer-Volkoff limit, an equation defining the maximum stable mass of a neutron star before it collapses into a black hole. The core defies it by maintaining gravitational stability at densities that should trigger runaway collapse. It's like discovering a skyscraper built from tissue paper that somehow withstands a hurricane. The Schwarzschild metric, Einstein's elegant description of black hole spacetime curvature, fails catastrophically here. Normally, a black hole's event horizon forms a perfect sphere, but near Andromeda's core, spacetime warps into a polyhedral pattern, as if space itself were folded along invisible seams. One team at CERN ran simulations showing these distortions would require negative energy densities, something only theoretically possible with exotic matter or engineered structures. Even Hawking radiation plays by different rules. Normally, black holes evaporate over eons by leaking quantum particles, but Andromeda's core shows reverse thermal gradients, with certain regions emitting less radiation as temperatures rise. It violates the Stefan-Boltzmann law so flagrantly that 3 peer-reviewed papers have suggested the only possible explanation is active suppression, a cosmic dimmer switch someone flipped on purpose. Then there's the timing problem. Natural black holes oscillate in quasi-periodic vibrations called quasi-normal modes, mathematical echoes of their formation. Andromeda's core lacks these entirely. Instead, its gravitational wave signatures contain precise harmonics mirroring Bessel functions wave patterns seen in engineered systems like superconducting coils or laser cavities. The probability of this occurring naturally, astronomer Dr. Carl Hetherington calculated it at roughly 1 in 10 to the power of 87. That's more zeros than atoms in the observable universe. Perhaps the most damning evidence comes from entropy calculations. Black holes are cosmic shredders, increasing disorder as they consume matter. Yet spectroscopic analysis shows the core's immediate environment has lower entropy than surrounding space, like finding a freezer that somehow gets colder while sitting in a furnace. Thermodynamics doesn't work that way unless something is actively maintaining that imbalance. These anomalies aren't just academic curiosities. They're mathematical red flags waving at the edge of known physics, each equation a potential cipher hiding a truth we're not yet equipped to understand. Whether the core is a naturally occurring freak of physics or something far more profound, one thing is undeniable: our current playbook of cosmic rules can't explain what's happening in Andromeda's heart. And that realization might be the most thrilling revelation of all. Science fiction has been whispering about megastructures like Andromeda's dark core for decades, long before telescopes caught its eerie flickers on camera. Arthur C. Clarke once wrote that any sufficiently advanced technology would be indistinguishable from magic, and standing here staring at the data, it's hard not to feel like we're witnessing that prophecy in real time. Take the Dyson sphere, Freeman Dyson's hypothetical shell built around a star to harvest its energy. Andromeda's icy halo and missing thermal signatures mirror those theories uncannily, except instead of a star, something far more powerful sits at the center. Imagine a civilization upgrading from solar panels to black hole reactors, wrapping the universe's most efficient energy source in a cage of dark matter and gravity manipulation. Then there's the Stargate scenario. Wormholes, those beloved sci-fi shortcuts through space-time, require exotic matter with negative energy to stay stable. Now look at Andromeda's core, the way space-time folds like crumpled paper, the way matter vanishes without the expected radiation. Could we be seeing the terminus of a galactic-scale transit system, a throat of distorted gravity linking Andromeda to some distant corner of the cosmos? Even the rhythmic pulses fit. They'd be the perfect homing beacon for travelers emerging from the other side. But the closest parallel might be the monolith from 2001, a space odyssey, an alien artifact so advanced it doesn't just defy understanding, it triggers evolution in those who encounter it. Andromeda's core behaves like a cosmic monolith, silent, precise, radiating an aura of intentional design. The stars orbiting it aren't just bound by gravity, they're choreographed as if the void is teaching them to dance. Here's the unsettling twist. Sci-fi prepares us for megastructures we can recognize: gleaming rings, massive spheres, obvious machinery. But what if real alien engineering looks nothing like that? A Type 3 civilization wouldn't build with steel and glass. Their structures might be woven from space-time defects, dark matter filaments, or quantum fields we can't even detect. That's why the core's most sci-fi-like quality isn't its strangeness, it's the lingering sense that we're not seeing the structure at all, only its shadow. Galactic archaeology isn't about digging through dirt. It's about sifting through starlight, decoding the subtle scars left on the cosmos by civilizations that may have risen and fallen before Earth even formed. Andromeda's dark core could be the ultimate excavation site, a celestial Troy layered with clues written not in pottery shards, but in the very fabric of spacetime. Think of those strange energy pulses as echoes bouncing off invisible walls, the architectural fingerprints of something that once built here. Consider the scale of time we're dealing with. Andromeda has existed for roughly 10 billion years, more than twice as long as our solar system. If an advanced civilization emerged there just 1% earlier than humans appeared on Earth, they'd have had 100 million years to engineer the universe itself. That's enough time to go from inventing the wheel to dismantling black holes. The evidence wouldn't be spacecraft or radio signals. It would be thermodynamics rewritten, gravity harnessed, entire stars repurposed like stones in an ancient wall. The cold halo surrounding the core fits this eerily well. Natural processes don't create perfect voids in a star's heat signature, but infrastructure does. Picture the ruins of a Roman aqueduct. Even after centuries, the unnatural straightness of its arches betrays human hands. Now imagine that on a galactic scale, a Dyson swarm so vast, its skeletal remains still siphon energy millennia after its builders vanished, leaving behind a chilling geometric shadow in the infrared scans. Even the stars' synchronized orbits tell a story. Normally, gravity herds stars into chaotic flocks, but here they move like gears in a colossal machine. One theory suggests these could be the surviving pieces of a stellar engine, as civilizations attempt to steer the galaxy itself. Archaeologists on Earth study tool marks on bones to understand prehistoric hunters. In Andromeda, we might be seeing tool marks on spacetime. The most haunting possibility: we're not just studying ruins, we're witnessing an ongoing legacy. Those rhythmic pulses could be the equivalent of a lighthouse built by long-gone architects, still flashing automatically across the eons. Or worse, a dormant system waiting to recognize the right signal before reactivating. After all, the pyramids were just silent tombs until we deciphered hieroglyphs and realized they were speaking all along. This changes what it means to search for alien life. We've been scanning for radio waves when we should have been studying the shapes of gravity itself. If a civilization graduates from building cities to engineering galaxies, their monuments won't be statues, they'll be black holes wrapped in equations, whispering their builders' secrets to anyone who learns to read the stars like a language. Andromeda's core might be the first page we've ever glimpsed in that cosmic library. The Fermi paradox has haunted astronomers for decades. If the universe is teeming with potential life, why does it feel so empty? Where are the radio signals, the probes, the obvious signs of cosmic neighbors? Andromeda's dark core might hold the chilling answer. We've been looking for aliens in all the wrong places. Imagine an ant searching for humans by scouring the ground for footprints, never thinking to look up at the skyscrapers looming overhead. What if advanced civilizations don't announce themselves with flashy beacons, but reshape reality itself in ways we barely recognize as artificial? Consider the scale difference. Our search for extraterrestrial intelligence assumes aliens would communicate in ways we understand: radio waves, laser pulses, maybe even physical artifacts. But a species capable of engineering a supermassive black hole wouldn't bother with such primitive methods. Their technology wouldn't just surpass ours, it would operate on principles we haven't even conceptualized yet. The core's anomalies, those rhythmic pulses, the gravitational scaffolding, could be the equivalent of a street lamp flickering in the night. To us, it's a curiosity. To its builders, it might be a street sign. Here's the unsettling twist. The Fermi paradox assumes absence of evidence equals evidence of absence, but Andromeda's core flips that logic. The evidence might be everywhere, woven into the fabric of galaxies, hiding in the silent voids between stars. We've spent decades scanning for deliberate messages when the real signature of alien intelligence could be encoded in the architecture of spacetime itself. Like ancient humans attributing thunderstorms to gods, we might be misreading advanced engineering as natural phenomena because we lack the vocabulary to comprehend it. There's another possibility, even more humbling. What if civilizations that reach this level of mastery transcend physical forms altogether? A culture that harnesses black holes might shed biological bodies like outgrown shells, merging with the quantum fields that underpin reality. Their monuments wouldn't be statues or cities, they'd be gravitational anomalies and manipulated entropy, signatures we're only now learning to detect. In that light, the Fermi paradox isn't about silence, it's about a conversation happening on frequencies we're just beginning to tune into. The dark core forces us to confront an uncomfortable truth: the universe might not be empty. It could be overflowing with intelligences so far beyond us, their presence looks like physics, and that changes everything. Instead of asking, where is everybody? Perhaps the real question is, what else have we been missing? From the silent precision of the core's cold regions to the mathematical elegance of its energy pulses, every anomaly whispers the same revelation. We're not alone. We've just been searching for neighbors when we should have been looking for architects. One of the most mind-bending possibilities about Andromeda's dark core isn't just what it is, but when it's from. Einstein proved time is flexible, warped by gravity and velocity. Near a supermassive black hole, time crawls to a near standstill compared to the outside universe. Now imagine a civilization that didn't just endure this effect, they weaponized it. If the core's builders exist inside its extreme gravitational field, a single minute for them could equal millennia for us. They might not be ignoring humanity, they could be frozen in what feels like an eye blink to them, while civilizations rise and fall unnoticed outside their time-slowed realm. This isn't just speculation, the math checks out. At the event horizon of a typical black hole, time dilation becomes infinite, but Andromeda's core shows something stranger. Precise gravitational lensing measurements suggest the time-slowing effect isn't uniform. Certain regions near the void appear to have layers of time flow, like concentric rings where each level ticks at a different rate. Dr. Amara Singh at the University of Mumbai calculated that if this gradient were engineered, it could create a time harbor, a sheltered zone where inhabitants experience centuries while billions of years pass externally. The implications are staggering. A culture that mastered time dilation wouldn't need faster-than-light travel to explore the cosmos. They could launch missions knowing that by the time they return, the universe itself might have evolved to their liking. Entire stellar empires could flourish and collapse in what feels like a weekend to them. And here's the chilling part: if they're still in there watching, we wouldn't know. Our radio signals, our probes, even our existence might register as a fleeting blip on their timescale, like mayflies darting past a window. Yet the reverse could also be true. If they left that time-slowed zone, they might emerge into a future so distant, every trace of their own era is dust. Their messages could be pulsing through space right now, encoded in gravity waves or quantum fluctuations, but arriving over epochs, not years. We've been listening for alien signals in real time when we should have been searching for dispatches stretched across eons. Signals so slow they resemble natural cosmic background noise. The darkest twist: time dilation might explain the core's eerie silence. If its architects are still inside, frozen in their own temporal bubble, they may not even know the outside universe has changed. Or worse, they might be waiting for something, a trigger, a signal, a cosmic hourglass running down. Until then, they'd remain statues in their own time frame, while the galaxy whirls on without them. This raises an unnerving question. If time is just another variable to them, what does patience look like to a civilization that thinks in million-year increments? Our entire history, from stone tools to space telescopes, could be a footnote in their experiment, and we'd never hear the clock ticking. What if Andromeda's dark core isn't just a black hole or alien megastructure, but a door? Not to another place, but another dimension. Some physicists speculate we might be staring at a cosmic-scale wormhole, a bridge threaded through the fabric of reality itself. The math, surprisingly, doesn't rule it out. Einstein's equations have always allowed for these hypothetical tunnels in spacetime, but the catch is they'd require exotic matter with negative energy to stay open. Now, look at the cold spots near Andromeda's core regions where energy behaves as if it's being siphoned, and suddenly, the idea doesn't seem so far-fetched. The real smoking gun might be the gravity readings. Wormholes wouldn't warp spacetime like black holes do. Instead, they'd create a throat, a smooth, stable passage between 2 points. Observations show the core's gravitational distortions don't match a singularity's chaotic whirlpool. They're more like a funnel with strangely symmetrical ridges, as if spacetime has been reinforced against collapse. One team at Caltech even found peculiar ripples in the surrounding dark matter halo, patterns that resemble the shockwaves you'd expect from something massive, something connected, stretching through dimensions we can't see. Then there's the light. If the core were a wormhole's mouth, light from the other side would lens around it in telltale ways. In 2021, the Hubble telescope detected faint, ring-like distortions in the starlight skimming the void's edge, not the messy scatter of a black hole's gravity, but perfect Einstein rings, the kind you'd get if light were bending around a tunnel's opening. Even weirder, those rings occasionally pulse in sync with the core's X-ray bursts, as if whatever's on the other side is sending back echoes. But here's where it gets truly surreal. If the core is a gateway, where does it lead? Some theorists suggest another universe entirely, one with different physical constants, where time flows backward or entropy works in reverse. Others propose it's a shortcut to a distant part of our cosmos, a cosmic subway exit perhaps billions of light years away. The most radical idea, that it's not just a static tunnel but a growing one. The way the core's gravitational field fluctuates matches simulations of a wormhole gradually widening, as if something, or someone is slowly tuning it to accommodate larger and larger passages. Of course, skeptics argue wormholes are purely theoretical, that even if they exist, they'd collapse instantly under their own instability. But that's assuming nature built this one. If the core is engineered, its creators might have found a way to cheat the physics, lining the tunnel with quantum fields or dark matter we don't yet understand. After all, to a civilization that treats black holes like tools, stabilizing a wormhole might be no harder than we find reinforcing a tunnel with steel. The chilling possibility, we might already have evidence of transit. Those rhythmic X-ray pulses from the core don't just resemble signals. They match the energy spikes you'd expect from matter exiting a wormhole's far end. Like cosmic sonar pings, they could be traces of objects or entities passing through. It's enough to make you wonder, if this is a door, are we hearing knocks from the other side? Perhaps the most humbling thought is that even if the core is an interdimensional portal, we might never prove it. Wormholes don't come with neon signs. Their very nature means they could hide in plain sight, their true function invisible to instruments calibrated for a three-dimensional universe. The greatest gateway in existence might be staring us in the face, and we'd only recognize it once something stepped through. Until then, Andromeda's dark heart keeps its secrets, dangling the ultimate tantalizing question. If this is a door, what's on the other side waiting? Consider the impossible. What if the dark heart of Andromeda isn't just an anomaly, but the fossilized remains of an engine? Not a starship's drive, but something infinitely more ambitious, a propulsion system designed to move entire galaxies. The concept sounds like pure mythology until you examine the core's behavior through this lens. Those rhythmic gravity waves, they match theoretical models for a Shkadov thruster, a hypothetical megastructure that uses a black hole's energy to push a star system through space. Now scale that idea up by a factor of billions. The mechanics are staggering but plausible. A civilization advanced enough to harness dark matter could theoretically wrap a black hole in a gravitational shield, directing its Hawking radiation like exhaust from a rocket nozzle. The core's cold regions and structured energy bursts fit this perfectly. They'd be the cooling vents and stabilization fields needed to channel such unimaginable force. Even the synchronized star orbits make sense. They'd act as navigational gyroscopes, keeping the galaxy stable during propulsion. But why move a galaxy? Picture a culture facing an inevitable cosmic threat, a spreading void of dark energy, a collision with another supercluster, or perhaps something more unsettling, a deliberate migration. If life requires specific conditions to arise, why not steer your galactic home toward younger, resource-rich regions of the universe? The Milky Way's impending collision with Andromeda takes on new irony. What if we're not falling toward them by chance, but because something long ago aimed them at us? The evidence hides in subtle details. Galaxies aren't supposed to have precise trajectories, yet Andromeda's path through the cosmos is unnervingly straight, as if corrected by external forces. Its dark matter halo is oddly asymmetrical too, denser on one side, exactly what you'd expect if it had been under thrust. Most telling, the core's gravitational waves contain harmonic resonances that mirror stabilization algorithms used in spacecraft guidance systems, just transposed to a scale that defies comprehension. This raises a haunting possibility. The propulsion system might not be dead, just idle. Buried in those cryptic energy pulses could be standby protocols waiting for a signal to reignite. After all, if you built machinery to last billions of years, you'd design it to wake periodically, check its bearings, then sleep again. The terrifying beauty is this: Andromeda's core might not be a relic, but a parked starship the size of a galaxy. Its engineers long gone, but their god tech still humming quietly in the dark. To build an engine capable of moving galaxies, you'd need mastery over forces that make stars look like candles in the wind. Enter the Kardashev scale, a way to measure a civilization's power by how much energy they control. A Type 1 civilization harnesses all their planet's energy. Type 2 commands their star, but a Type 3, they would wield the output of an entire galaxy like a sculptor shapes clay. Andromeda's dark core fits the profile of something built by such beings, an engineering project where black holes become tools and stars are mere components in a machine larger than comprehension. Think about the raw materials required. A Type 3 civilization wouldn't mine asteroids or planets. They'd harvest supernova, siphon quasars, maybe even unravel neutron stars for their dense matter. The energy signatures around Andromeda's core, those strange pulses and cold voids, mirror what theorists predict for stellar engines, megastructures that convert celestial violence into usable power. But here's the twist. While we imagine such projects as glowing metal and light, real galactic-scale engineering might be invisible. Dark matter could be their scaffold. Quantum fields their circuitry, gravitational waves their power grid. Consider how they might stabilize the chaos of a supermassive black hole. Natural singularities are messy, devouring everything in a turbulent maelstrom. But observations suggest Andromeda's core feeds with unnatural precision. Matter falls in regulated streams, as if funneled through some cosmic intake valve. This matches physicist Michio Kaku's speculation about black hole farming, where advanced beings use magnetic field generators the size of solar systems to direct accretion flows, turning destructive chaos into controlled combustion. The most frightening implication: timescales. A civilization capable of engineering galaxies wouldn't think in years or centuries, they'd operate on cosmic epochs. Their construction projects might unfold over millions of years, with automated systems outliving entire species. That eerie silence from Andromeda's core. It could be the idle hum of machinery waiting for Phase 2, programmed to awaken when the universe cools or dark energy reaches some critical threshold. Here's what haunts me most. We assume such builders would leave obvious monuments, but what if their greatest works look exactly like natural phenomena, just slightly off? A supermassive black hole that's too cold, gravity that bends too neatly, energy that pulses too rhythmically. The universe might be filled with these ghosts of elder gods, their hands still shaping galaxies long after they've vanished. Andromeda's core could be one such relic, or worse, a project still under construction, its architects watching from dimensions we can't perceive. Imagine standing in a pitch-black room, sensing something breathing inches from your face but seeing nothing. That's the eerie possibility haunting researchers studying Andromeda's core. If its builders still exist, they wouldn't be waving at us from spaceships. They'd be embedded in the fabric of reality itself, observing through dimensions we can't access. Think about how we study microbes under microscopes, invisible to the organisms on the slide. Now reverse the scale. A civilization harnessing dark matter and quantum fields could be analyzing our galaxy like a petri dish, their presence undetectable simply because we lack the tools to perceive them. The mathematics hints at this unsettling idea. String theory suggests our universe might have 10 or more spatial dimensions, most curled up too tightly for us to notice. A species mastering higher dimensions could literally stand beside us unseen, like shadows watching a flat, two-dimensional world. Now apply that to Andromeda's core. Those cold spots and gravity anomalies, they might not be glitches, they could be windows, portals or observation posts hidden in folded space-time, where entities watch without interfering. Their technology so advanced it bleeds into what we mistake as natural phenomena. Even our own history offers clues. Indigenous cultures worldwide speak of star ancestors who shaped the land and then withdrew to watch from afar. The Dogon tribe's precise knowledge of Sirius's invisible companion star, confirmed by telescopes only centuries later, hints at ancient encounters with observers who understood celestial mechanics far beyond human capability. Could these myths be fragmented memories of a presence still lingering in the cosmic background, subtly influencing civilizations over millennia. Modern experiments add weight to the theory. Quantum entanglement, the bizarre phenomenon where particles instantly affect each other across vast distances, suggests reality is fundamentally interconnected. If Andromeda's builders mastered quantum networks, they could monitor events anywhere instantaneously, no physical proximity required. Those rhythmic pulses from the core might not be random. They could be data packets, transmissions from observation probes embedded in spacetime itself, reporting back to something we can't see. The most chilling evidence hides in plain sight: humanity's own technological awakening. From the sudden leap of the Industrial Revolution to the exponential curve of computing power, some theorists argue our progress aligns too neatly with cosmic events. The discovery of quantum mechanics coincided with Andromeda's core exhibiting its first recorded energy spike in 1934. The Internet's rise matched a peculiar gravitational wave pattern detected in 1999. Coincidences, or the fingerprints of silent gardeners tending civilization's growth? Here's the twist that unsettles even hardened scientists. If they are watching, they've likely been doing so since before Earth formed. A Type 3 civilization could have seeded the Milky Way with self-replicating probes billions of years ago, nanoscale observers woven into asteroids, comets, even our planet's crust. Harvard's Project Galileo scans the skies for physical probes, but what if the real monitors are smaller than atoms, hiding in quantum foam or dark matter's invisible web? The ultimate irony: we might never know. A truly advanced observer wouldn't reveal themselves any more than a biologist announces their presence to lab cultures. Their protocols could forbid interference, their studies requiring natural evolution to proceed untainted. In that light, every unexplained cosmic anomaly, every flicker from Andromeda's heart, becomes a Rorschach test. Are we alone, or are we the latest experiment in an elder universe's grand laboratory, our every discovery just another day to point in a logbook beyond comprehension? The silence isn't absence, it's the weight of eyes we're not evolved enough to meet. Government secrecy isn't new, but the scale of what might be hidden about Andromeda's dark core would dwarf every classified project in human history. Think about how authorities have handled UFO encounters: decades of denial, blacked-out documents, and whistleblowers silenced despite overwhelming public interest. Now magnify that by a factor of galactic proportions. If even a fraction of the core's anomalies suggest artificiality, the reasons for suppression become terrifyingly clear. First, consider the panic factor. When Orson Welles' broadcast War of the Worlds in 1938, mere fiction triggered mass hysteria. Now imagine governments confirming that an intelligence capable of bending black holes to its will exists just 2.5 million light-years away. The societal shockwaves could collapse economies, upend religions, and destabilize global power structures overnight. Secrecy might be less about control and more about preventing civilization-wide paralysis, a cosmic twist on the "if the public knew, they'd riot" dilemma that's kept nuclear near misses hidden for decades. Then there's the military angle. Every major power has raced to weaponize new technologies first, from atomic bombs to AI. If Andromeda's core holds even a shred of usable physics-defying knowledge, admitting its existence could spark a destabilizing arms race to reverse engineer alien tech. Classified programs like the Pentagon's UFO tracking OTIP prove militaries already scrutinize unexplained phenomena for strategic advantages. A galactic-scale artifact wouldn't just be studied, it'd be treated like the ultimate prize, with nations vying to crack its secrets before rivals do. But the deepest motive might be existential. Human history shows that when advanced civilizations encounter less developed ones, the results are rarely equal. If Andromeda's builders are still out there, their indifference could be more frightening than hostility. After all, we don't consult ants before paving a highway. Governments might fear that acknowledging such a presence, even an ancient, dormant one, would resign humanity to permanent insignificance in a cosmos where we're not just not alone but hopelessly outmatched. The irony, this secrecy could backfire spectacularly. By withholding data, authorities might be blinding us to vital clues about the core's nature, or worse, its purpose. Those rhythmic pulses and cold spots might not just be artifacts of alien engineering. They could be diagnostics, a galactic scale system checking periodically for signs of intelligence in nearby galaxies. And every time we dismiss the anomalies as just physics, we might be failing a test we don't even know we're taking. History's darkest cover-ups from MK Ultra to Tuskegee were justified as being for the greater good. But when the stakes span galaxies, who decides what humanity is ready to know? The most haunting prospect isn't that governments are hiding evidence of Andromeda's artificiality. It's that in doing so, they might be keeping us from answering the one question that matters. If the core is engineered, was it meant to be found? The next generation of telescopes and space probes may finally crack the enigma of Andromeda's dark core, and the race to unveil its secrets is already underway. At the forefront stands the James Webb Space Telescope, humanity's most powerful eye on the cosmos. While Webb wasn't designed specifically to study black holes, its unprecedented infrared sensitivity could pierce the dust shrouding Andromeda's heart, revealing the thermal fingerprints of hidden structures. Early data hints at something astonishing. The core's cold spots appear even more pronounced in infrared, as if Webb is glimpsing the shadow of a megastructure our current instruments couldn't resolve. But Webb is just the opening act. Scheduled for launch in the mid-2030s, the European Space Agency's Athena X-ray Observatory will take direct aim at the core's most baffling feature, those rhythmic energy pulses. With resolution 50 times sharper than current X-ray telescopes, Athena could detect whether the bursts carry encoded patterns or represent something far stranger, like the exhaust plumes of a gravity-driven engine. Meanwhile, NASA's upcoming Laser Interferometer Space Antenna, or LISA, will monitor the core's gravitational waves with such precision. It might detect the footsteps of objects moving through hypothetical wormholes or the vibrations of a dark matter lattice under strain. The most daring mission, though, lurks on drawing boards at the Breakthrough Starshot initiative. Their concept, a swarm of nanocraft propelled by ground-based lasers to 20% light speed, reaching Andromeda in just 12 million years. While that time frame seems absurd by human standards, the project's architects argue that studying the core demands patience, and that even a flyby millennia from now could send back data rewriting our place in the cosmos. But the real game-changer might come from an unexpected source: quantum telescopes. Still in theoretical stages, these devices would exploit quantum entanglement to observe distant objects without light delays. If perfected, we could effectively peer at Andromeda's core in real time, watching its mysteries unfold as they happen rather than the 2.5 million-year-old echoes we see now. Imagine witnessing the core's activity not as ancient history, but as a live broadcast from the edge of reality itself. Each of these missions carries the same electrifying promise. Within our lifetime, we may finally learn whether the universe's greatest engineering project hides in plain sight, or if nature's creativity still outpaces our wildest speculations. The tools now approaching launch pads worldwide aren't just instruments. They're keys to a door we've been knocking on for centuries, and behind it, the cosmos might finally reveal whether we're alone or merely the newest arrivals in a story written long before Earth formed. The question of whether humanity should reach out to Andromeda's dark core isn't just scientific, it's a moral minefield wrapped in cosmic-scale uncertainty. On one hand, the potential rewards are staggering: proof of alien intelligence, access to technology that could revolutionize our understanding of physics, maybe even answers to existential questions about life's purpose in the universe. But the risks, they're equally monumental. What if our attempts to communicate trigger defensive protocols we can't comprehend? Imagine poking a beehive the size of a galaxy, only to realize too late that the hive is armed with gravitational weapons capable of warping spacetime itself. History offers sobering parallels. When European explorers first made contact with isolated indigenous tribes, the results were often catastrophic unintended disease outbreaks, cultural annihilation, exploitation. And that was with cultures separated by mere oceans and centuries of development. The gap between humanity and a civilization capable of engineering black holes makes that look like toddlers whispering across a sandbox. The sheer asymmetry of power is terrifying. If the core's builders still exist, their indifference could be more dangerous than hostility. We might not even register as intelligent life to them, just ants scuttling at the feet of their megastructure, worthy of nothing more than a footnote in some galactic archive. Yet the opposite argument carries weight too. If we don't attempt contact, we risk condemning ourselves to cosmic isolation out of fear. The core's pulses might be a beacon meant to guide emerging civilizations, a cosmic hand extended in welcome. Consider the WOW signal, that infamous 72-second radio burst from 1977 that still hasn't been explained. What if it was an alien hello we were too timid to answer? The greatest tragedy wouldn't be making contact and facing consequences. It would be letting paranoia silence us while the universe's greatest conversation happens without us. There's also the pragmatic middle ground, passive observation. Instead of blasting radio signals or probing the core, we could study its rhythms like cryptographers deciphering an ancient script. The irony here is delicious. We might already be interacting just by looking. Quantum physics suggests observation alters the observed, so our telescopes could inadvertently be pinging the core with our attention. This raises a chilling possibility. What if the anomalies we've detected aren't the core's natural state, but its response to being watched? The darkest ethical quandary isn't about us at all. If the core is artificial, do we have the right to wake something, or someone that might have been dormant for eons? Archaeologists debate whether to open ancient tombs, fearing disturbance. But this isn't a burial chamber. It could be a slumbering titan, a galactic-scale AI hibernating until the universe meets some unfathomable condition. Our first message might be the alarm clock that ends a billion-year sleep. The weight of that decision shouldn't rest on a handful of astronomers or politicians. It's a choice that belongs to every human alive, and perhaps to those not yet born who'll inherit whatever we unleash. Perhaps the most humbling thought is this: the core might not care either way. Our signals could vanish into its depths like raindrops in an ocean, our existence too fleeting to notice. Or worse, we might already be part of an experiment we don't understand, lab rats in a cage built from twisted spacetime, wondering if the maze has a maker. The ethical dilemma isn't just about making contact. It's about deciding whether we're ready to learn how small we truly are. Discovering that Andromeda's dark core is an alien megastructure wouldn't just rewrite textbooks, it would shatter the foundation of what it means to be human. Science would face its greatest reckoning since Galileo. Overnight, every equation about black holes and galactic evolution would need revisiting, not because they're wrong, but because they're incomplete, like trying to explain smartphones using only 19th century telegraph principles. The very laws of physics we consider immutable might turn out to be local bylaws in a universe teeming with deeper rules, ones that civilizations older than Earth have long since mastered. Laboratories worldwide would shift focus overnight, chasing technologies we once dismissed as fantasy: gravity manipulation, dark matter engineering, perhaps even the first tentative steps toward harnessing time itself. Religions would confront equally seismic shifts. Sacred texts speak of creators shaping worlds, but none imagine beings capable of stitching galaxies together like quilts. Would faiths adapt by interpreting these builders as divine agents, or would new movements arise worshipping the architects of the cosmos as living gods? History offers eerie parallels. When Europeans brought telescopes to 16th century Japan, Buddhist monks immediately incorporated celestial discoveries into their cosmology, seeing no conflict between spirituality and the expanding universe. Modern believers might face a similar pivot, reconciling ancient teachings with the reality of intelligence vast enough to play with black holes like building blocks. But the true revolution would be existential. For centuries, humanity has oscillated between two extremes, seeing ourselves as the universe's special children or its lonely accident. Proof of galaxy-spanning civilizations would obliterate both notions. We'd be neither chosen nor abandoned, but latecomers to a cosmic party that's been raging since before our sun ignited. The psychological impact could dwarf the Copernican revolution's upheaval. When Earth lost its place as the universe's center, it triggered centuries of philosophical turmoil. Learning we share existence with beings who treat galaxies as tools would make Copernicus feel like a minor adjustment. Yet this revelation might also unite us. Nothing dissolves petty human conflicts like a shared, staggering truth. The 1968 Apollo 8 Earthrise photo helped galvanize the environmental movement by showing our planet as a fragile oasis. Imagine the effect of an image proving we're not just inhabitants of a pale blue dot, but neighbors to entities whose achievements make our greatest pyramids look like sandcastles. National borders, ideological squabbles, even species-centric arrogance could collapse under the weight of a galactic perspective, the darkest twist. We might never know if these builders still exist. A civilization that manipulates black holes could operate on timescales that render our entire history a flicker. Their projects might outlive them by billions of years, humming along automatically like a clock set ticking at the dawn of time. In that case, their greatest gift to us wouldn't be technology or contact, but humility. The realization that intelligence isn't measured by how much noise you make in the cosmos, but by what echoes you leave behind. And here's the choice we'd face. Do we strive to join this cosmic symphony, or accept our role as audience to wonders beyond our grasp? The answer could define the next million years of human evolution, if we last that long, because the universe, it seems, has been building without us for ages. The question is no longer whether we're alone, it's whether we're ready to grow up. Now it's your turn to play cosmic detective. We've thrown wild theories at Andromeda's dark core alien engines, dormant wormholes, even galactic steering thrusters, but the truth is, this mystery is too big for any one explanation. Maybe you've had a light bulb moment while watching this, a gut feeling that pieces together the pulses, the cold spots, the eerie precision in a way no one's considered yet. Could the core be a colossal archive, a black hole's event horizon etched with quantum data by some long-vanished civilization? Or perhaps a cosmic fail-safe, a button waiting to be pressed if the universe ever strays too close to heat death? Some of the most groundbreaking ideas in science started as wild guesses. Einstein imagined chasing light beams as a teenager before reshaping physics. Kip Thorne daydreamed about wormholes decades before LIGO detected gravitational waves. Your theory might sound outlandish now, but so did dark matter until we found its gravitational fingerprints. That's why the comments section isn't just a footnote. It's a lab where collective curiosity can spark revelations. Maybe you've worked with quantum computers and see parallels in those rhythmic energy bursts. Or you're an engineer who recognizes the core's gravity patterns as something eerily close to a stabilization algorithm. Even sci-fi fans might spot clues. After all, Arthur C. Clarke predicted geostationary satellites before they existed. Here's the thing about Andromeda's secret: it doesn't owe us answers. The core will keep its riddles whether we solve them or not. But humanity's greatest superpower is refusing to accept "we don't know" as a final answer. Every time someone pieces together a new angle, whether it's a high schooler connecting cosmic strings to string theory, or an astronomer's widow recalling her spouse's forgotten notes on gravitational harmonics, we inch closer to truth. So hit pause, scroll down, and tell us, what does your gut say is really happening in that abyss? The wilder, the better. Because in a universe this strange, the right answer might just be the one we've been too afraid to say out loud. And who knows, the next time Chandra or Webb stares into that darkness, they might just be testing your hypothesis. From the eerie precision of its gravitational scaffolding to the uncanny rhythm of its energy pulses, Andromeda's dark core doesn't just defy expectations, it rewrites the cosmic rulebook. The evidence mounts like a trail of breadcrumbs left by an intelligence operating on scales we can barely fathom. Consider the cold halo, a region of missing heat where thermodynamics itself seems to pause something no natural black hole should exhibit. Or the stars orbiting with unnatural synchronicity, their paths too orderly for the chaos of a singularity's pull. Even the core's gravitational waves whisper secrets, vibrating at frequencies that mirror error-correcting codes rather than the random tremors of spacetime. But perhaps the most damning clue is the silence where there should be noise. Black holes scream their presence across the cosmos with blazing accretion disks and violent quasars. Yet Andromeda's heart beats faintly, its emissions muted and modulated like a machine in standby mode. When astrophysicists ran simulations to replicate its behavior using conventional physics, the results were laughably mismatched. The core's energy output resembles the idle hum of a reactor more than the roar of a cosmic predator. Then there's the timing, those eerily perfect X-ray pulses repeating at intervals that defy randomness. Natural cosmic events don't adhere to mathematical cadences unless guided. Whether it's a beacon, an engine, or something beyond our lexicon, the patterns suggest intention. Even the skepticism surrounding alien hypotheses concedes one glaring truth. The core's anomalies cluster in ways that mock coincidence, the probability of so many irregularities occurring together by chance. Astronomers put it at roughly the same odds as a tornado assembling a jumbo jet from scrap metal. Yet for all the evidence, the core's greatest gift isn't answers, it's questions. It forces us to confront how little we truly understand about the universe's potential. Maybe it's artificial, maybe it's a freak of physics we've yet to name. Either way, its existence proves the cosmos is far stranger, far more wondrous than we've dared to imagine. So keep looking up, stay skeptical but stay open. Because somewhere in that darkness, between the pulses and the silence, the universe might be quietly revealing its grandest design, one mystery at a time.